Okay, we are at chapter 21 of Conceptual Physics, Musical Sounds. This is a uh, short chapter, and it's the last chapter that we're going to cover, Physics 1305. Um, so let me dismiss uh, my image here. And in this lecture, we're going to cover the following topics and help you understand noise and music, the difference between noise and music, musical sounds, pitch, sound intensity and loudness, quality, musical instruments, Fourier analysis, and digital versatile discs, DVDs. So let's get started. Noise corresponds to an irregular vibration of the eardrum produced by some irregular vibration in our surroundings, a jumble of wavelengths and amplitudes. White noise is a mixture of a variety of frequencies of sound. We used uh, to babysit our seventh grandchild here at the house, and we always had a white noise generator. And we would put him to nap and have that white noise generator, and he'd stay napping for a while. And I think it was just generally white noise, but you could pick like raindrops or ocean waves. Those are just white noise generators, and they're pretty random. They're not periodic. They're not. It's not by any means music. Um, so the music, however, is the art of sound and has a different character than noise. Musical sounds involve single frequency tones identified as musical notes. The distinction separating music from noise is subjective. Now, it says um, musical sounds involve single frequency tones when in reality a lot of a trumpeter may be playing a single note, but there's a whole bunch of overtones that make up that sound. I forget what the I think a flute can generate a almost perfectly pure tone, but other instruments, they have some overtones, which we'll learn about a fundamental and the first harmonic, second harmonic, and so forth. And they usually have multiple overtones that you can hear with besides the fundamental. And you can see here that there's a regular pattern to these to this wave. Um, so that's part of what separates music from noise. Some people might argue that some music is noise. I happen to be a jazz fan, and I was listening to John Coltrane's "My Favorite Things," and my grandson in the back asked, "Is this music?" So I guess he doesn't appreciate John Coltrane. Anyway, a musical tone has three characteristics: pitch, the frequency of sound waves received by the ear. High frequency equals high pitch, low frequency equals a low pitch. Intensity, the perceived loudness of sound. We'll get into intensity and the decibel scale in a little bit. And quality, characteristic timbre of a tone. It looks like timber, but it's timbre. It's a French word. Um, so the characteristic, we can call it quality, but it's the characteristic timbre of a tone, determined by the relative prominence of harmonics, and it's determined by the presence and relative intensity of various partial tones. That we'll discuss that more when we discuss Fourier analysis. Okay, music is organized on many different levels. Most noticeable are musical notes. Each note has its own pitch. We can describe pitch by frequency. Rapid vibrations of the sound source, high frequency, produce sound of high pitch. Slow vibrations of the sound source, low frequency, produce a low pitch. You know, you happen to have a piano at home, even if it's an electric piano, you press way over to the left-hand side, you'll get a very, very low tone. If you press over to the right-hand side, you get a very, very high tone. And if you were to look inside your piano, unfortunately, if it's electronic, you can't look inside. But if you look inside your piano, you would see that where you're striking the extreme left hand keys, you're pressing very long, very heavy, thick wires. Whereas if you press on the right hand side, you're uh, with the hammer, you're hitting very short and very thin wires. It becomes obvious when you see someone playing a harp. The lower tones are the longest ones away from the harpist, and the shorter ones are the ones that are resting on her shoulder. Okay, musicians give different pitches, different letter names. A, B, C, D, E, F, G. Notes A through G are all notes within one octave. Now, become aware that this is, or be aware that this is a Western scale. There are other scales that other countries use. This is a Western scale that we're used to. You multiply the frequency on any note by 2, and you have the same note at a higher pitch in the next octave. So middle A is 440 hertz. If you one octave up, you'll still have A, but it's at 880 hertz. It's a doubling. The next A is twice the frequency of middle A 440. So a piano keyboard covers a little more than 7 octaves, and it shows it here. You can see with each is C1 is 32.7, C2 is 65.41, C3 is 130.31 hertz, and so on and so on. And each C, C4, C5, C6, C7, C8, it's a doubling of the previous one. So you double the frequency, you've gone up an octave. Different musical notes are obtained by changing the frequency of the vibrating sound source. This is usually done by altering the size, the tightness, or the mass of a vibrating object. You tune a guitar by tightening the little knob at the top of the neck. If you tighten it, it goes higher. If you loosen it, it goes lower. Also, you can if the guitar is already tuned, you can press on the frets and shorten the length of the guitar string and make it go higher. High frequency tones have a very short lambda, very short wavelength. Low frequency tones have a longer wavelength. Okay, high-pitched sounds used in music are most often less than 4,000 hertz, but the average human ear can hear sounds with frequencies up to 18,000 hertz. Some people and most artists can hear tones of higher pitch than this. The upper limit of hearing in people gets slower as they grow older. I can attest to that. I'm 69 years old at this recording, and I had a hearing test, and especially my left ear is very diminished. So as you get older, your hearing does degrade, especially at the higher frequencies. I have a beautiful wife that has a very high voice, so quite often she has to repeat what she's saying to me. That's just life as you get older. A high-pitched sound is often inaudible to an older person, and yet may be clearly heard by a younger one. Okay, that's the end of part 1. We'll go on with part 2 in the next video.